Let me first thank all my subscribers and viewers who have taken keen interest in watching my videos and posting excellent questions on my channel. Now, there have been a lot of questions on statistics relating standard deviation, so I've combined 4 questions in this particular video to answer them one by one. So we'll discuss about relation between variance, standard deviation, mean, range, and z-score with the help of examples. For greater details in any of these topics, I'll provide you links on the top in the form of a quiz or link to the playlist, which will give you practice questions, right? So the very first question here is, which is the incorrect statement about standard deviation? Incorrect statement about standard deviation. 4 options are: the variance is the square root of the standard deviation. B, the standard deviation is often called the average distance of the measurements from the mean. C, the standard deviation is expressed in the same units as the data. D, the standard deviation is always a positive quantity. Well, the first one here is okay, so you can actually pause the video, answer, and then look into my suggestion. That'll be better, right? Okay, now here is the answer. The first one, the variance is square root of standard deviation, is absolutely incorrect. Actually, it is that the variance is square of standard deviation. Okay, so the variance is not square root, but it is square of standard deviation. We denote standard deviation by this letter, sigma. Okay. Now let's move on and understand the correct statements also. Standard deviation is often called the average distance of measurement from the mean. So that really means if I give you a mean value, then standard deviation is the average distance from the mean, right? So this is, let us say, standard deviation. This is mean. In that case, what should be the range? So that will answer one of our questions to follow, right? So it's very important to understand. So if I go the same distance away on either side, another standard deviation, I get my lower bound and upper bound, right? So this becomes range. You got it, 4 standard deviations. Do you see that? So I could say that range equals to 4 times standard deviation. Now, this is extremely important formula, I think, based on which I have a lot of questions to answer. So that will answer most of them, right? Okay. Next question, I should say information about standard deviation is, the standard deviation is expressed in the same units as the data. Important. Always, always, always write units. For example, if the height is given in centimeters, standard deviation is in centimeters, right? If the average height is, let us say, 170 centimeters, standard deviation will be, let's say, 2 centimeters, okay? Units are very important. Fourth, the standard deviation is always a positive quantity, correct? Positive quantity away from mean. So we also mentioned this as absolute value. So whenever you calculate standard deviation, you have to write the absolute value. Perfect. So these 3 are very important. That's why I took them up, and I hope most of your questions will be answered by now, but we'll take them one by one. So the next question here is, mean of students in a high school is 16.5 years and the standard deviation is around 1.35 years. Estimate the range of the above data. Perfect. So now you understand what I was trying to say, right? You can always pause the video, answer the question. I'll grab the calculator by that time. Okay. So, I hope you got your answer. Let's work on it. So what we are given here is mean of students, right? So again, we have this mean. Let's say mean of students is given to us as, I'm writing M capital for mean. Okay, 16.5 units are years. Important, right? And standard deviation is around 1.35 years. So that basically means that, okay, let me just draw a line here. That depends on the range. Is that okay? That's the mean. Standard deviation is, let us say, 1.35 years. So if you move this side, you have to go 1.35. Think about this point as the origin, okay? 0. Standard deviation is always positive. It is both sides. Do you see that? Standard deviation of 1.35. So the data should be from where to where. That is what range is. Range is minimum, you can say lower bound and upper bound kind of things, okay? So that is 2 standard deviations away, right? 2 standard deviations. So one more standard deviation on either side. Do you get an idea? Is that okay? So that clearly shows what the range is. Range is difference between, let's say, lowest to highest. Is it okay? So between these two, lowest to highest, we call this as range. So it is 1, 2, 3, 4 standard deviations. Perfect. So that gives you the answer, which is basically 4 times 1.35 years. Units are very important. Well, in the options I didn't write units, but remember you have to mention units if the question is normally asked, right? 4 times, let me do 4 times 1.35 equals to, in decimals, 5.4. 5.4. Now the idea is, I got 5.4. That clearly shows that the range is more than 5. So we'll select 6 as the right option, right? Basically, this is when the data is, we don't have any outliers and things like that. So to be on safe side, we have to assume 6. This is kind of minimum range, I should say, right? Range, let me write this as minimum. Okay, so consider that to be the minimum range and take a figure which is rounds to higher if I give you numbers like this, right? So I haven't given you decimal numbers to really match it up. So the answer is 6. It is important since in SAT and some other papers you may get round numbers like this, right? So let's move on. The question here is, mean of students in a class is 16.5 years. So again, we working with the same value. Let me just, mean is 16.5 years. And the standard deviation is around 1.35. So away we go. Both sides, 1.35. What can be the value of standard deviation if a 18-year-old student is replaced by 16-year-old, right? So what we have here is some data, right? We have some data here based on which we have calculated that the mean is 16.5 years age and standard deviation is 1.35. What can be the value of standard deviation if a 18-year-old, right? So if I add 1.35, what do I get? Let's do it. Always use calculator if allowed. Otherwise, these are simple calculations which could be done without calculator. Is it okay? Now, because I want to go to 2 decimal places, So that's why I'm using this calculator. Correct. Now let's try to understand this question once again. What can be the value of standard deviation if a 18-year-old, now one standard deviation away is 17.85, 18 is outside, kind of here, right? 18 years. Old student is replaced by 16. So we take away 1 and we bring it another 1. So the other student which we bring in is kind of here. We introduced as 16.5 and we take away a data point from whose age is 18. Now it says, what can be the value of standard deviation if this is done? Options are these. Now what we understand here is we have taken away a data point which is away from one standard deviation, right? But we have introduced one which is closer to mean. So standard deviation will be more compact, correct? So it will kind of reduce. Is it okay? So we're looking for a number less than. So we're looking for less than 1.35, correct? So the only value here is 1.32. Therefore, that is the correct option. Is that okay? So information is complete. We can derive at that result knowing fully well that the data point is closer now than earlier. So the standard deviation is actually the variation or spread of data from the mean. Now it's more compact as we removed 18, which was away, by 16, which is much closer to the mean. That's the concept. Okay, so let's move on. Now here is another question from my subscriber. Let me first thank him for this excellent question, and based on this only, I have actually made this video. The question here is, at certain company, the average starting salary S for a new worker is $25,000. The actual salary has an absolute deviation of at most $1,800. Find the range of starting salaries. I have modified the question a bit. You have to write the inequality to find the answer. But in my explanation, I will explain you how to write the inequality also, right? So that's the question on which we are going to work. It again relates mean with the range, correct? It relates mean with the range of data which we are trying to have. What we are given here is that the mean is equal to 25,000, right? So all units are in dollars, okay. And the deviation is at most 1800. That means away from the mean. Always take deviation as how much are you going away on both the sides from the mean. So that away from the mean is plus 1800 or minus 1800. Now standard deviation is always positive, but when we talk about range, we have to look at both the sides. So what you should do is, you should figure out 4 standard deviations. That should give you the range. So the range actually is, as we did earlier in one of our videos, range is 4 times the standard deviation, correct? So let me write down the formula very clear. Range is equals to 4 times standard deviation, which is 4 times 1800, right? And that gives you equals to 7200. So the answer is B. So you can always write inequality that range is less than 4 times 1800. So range is less than, you can say equal to 4 times standard deviation. And then when you fill in the standard deviation, you get your answer, right? So they also say absolute deviation, right? So that really means always you have to write deviation as a positive number, right? Both sides. That gives you a hint, kind of say, hint in the question itself to correctly answer. I hope that's absolutely clear. And now let's move on to answer the next question, which is based on z-score. Okay, the question here is, the mean of a data set is 25.3 centimeters. So in this case, we are given mean equals to 25.3 centimeters. Standard deviation is 3.6 centimeters. Standard deviation is always positive and includes units. What is expected value of z-score of? So we have z-score of minus 1.25. Now z-score is related with standard deviation, right? So how many? Z-score is like multiple of standard deviation or sigma. Is it okay? That is what z-score is. Now it says, what is expected value with z-score of this? Second, you should remember z-score is a number, not a does not have no units. So as we go along, I'm going to answer many more questions. Look for the links on the top, which will give you practice questions based on z-score. Okay. Now, so what we have got here is multiple of standard deviation. So if I say z-score is minus 1.25, then we are saying how far away the data point is from the mean. Correct? So what we are going to do is we are going to multiply 1.25 negative with the standard deviation, which is 3.6, and add this to the mean, which is 25.3. That is how you're going to get the value, right? You could have written the other way also, 25.3, or no harm, 25.3 take away 1.25 times 3.6, one and the same thing. So we'll do that. So we have 25.3 take away 1.25 times 3.6 equals to, in decimals, 20.8. So we get 20.8. A is the right option for us. Perfect. So that is how you're going to answer such questions based on z-score. I'm Anil Kumar, and I hope that really helps you to understand how standard deviation is linked with, we started with definition, mean, range, and now z-score. Feel free to post questions and your suggestions, and if you like, you may subscribe. Thank you and all the best.